Alright, so guys, we are going to talk about the matrix. We're going to talk about how to find the dimensions of a matrix, how to add, subtract, scalar multiply, and plain old multiply, as well as to find determinants and inverses. Whew! It sounds like a lot, but it's actually going to be pretty easy. Like, they're easier than you think it's going to be to work with, okay? So first off, let's define what is a matrix. Well, a matrix is just a rectangular array of numbers, okay? You've got rows, and you've got columns, and then you've got numbers inside of them. That is a matrix. So your matrix could have different sizes depending on your number of rows and your number of columns, okay? Now each one of these numbers is called an entry or an element, and when we're like adding or subtracting, we just have different rules for what we do with those elements, okay? So let's start by talking about the order of a matrix. What you always do on this is you're always going to talk about row by column. Now your rows are going to be these ones right here, going like that. Those are your rows, okay? And your columns are going to be going straight down. So rows are horizontal, columns are vertical. So how many rows in A do we have here? There's row 1 and row 2. So there's a total of 2 rows, right? How many columns do we have? This is column 1, this is column 2, this is column 3. So we would call this a 2 by 3 matrix because it has 2 rows by 3 columns. Okay, let's go to the next one. And Chloe, how many rows does that matrix have? 4. There are 4 rows, great. And how many columns? 2. So this is a 4 by 2 matrix, right? Thanks, Chloe. So now you guys, well, this one's kind of easy. Why is this one easy? It's a square matrix, that's even the vocab word, nice job. Same number of rows as number of columns. So what would we call this last one? That's a 3 by 3 matrix, okay? Now, some of the operations have specific rules about the orders, and so we have to make sure we have the same strategy for labeling these, okay, for identifying the order. So, what is the rule for determining the order? Row by column. Okay, thank you. Let's keep on going here. So now, if we are adding or subtracting, okay, the rule is they have to have the same order. And in that case, you're just going to find that this kind of tells you in math language what you're going to do, but you're just going to add or subtract the corresponding elements. Corresponding means they're in the same position, okay? But what you have to be careful of is you have to have, you see right here, the same order, or they have to be the same size. So we're going to highlight that. And then let's switch over to your assignment, and we're going to do 1, 3, and 6. So here's what your assignment looks like, and let's do number 1. So to start us off, Brindley, what is the size of this first matrix, or the order of that first matrix? Good, what about the second one? So are they the same size? Yes, so then we can add, okay? So now when we're going to add these here, what we're going to do is the corresponding elements add together. So I'm going to highlight this. So 1, which is in the first row, first column, would add with what? What do you think? 5, because it's in the first row, first column. Okay, what would this 5 right here add with? 3. Okay, let's keep going here. What about this second 5? 0, and we're seeing that it's corresponding numbers add, so if they're in the same position, meaning if it's in the second row, second column, it adds with the other element in the second row, second column, right? We see the fun color coordination there, right? So now, let's just add those together. What is 1 plus 5? Good, class. 5 plus 3 is 8. 5 plus 0 is 5. 0 plus 1 is 1. 3 minus 5 is negative 2. Negative 2 plus 0 is negative 2. Do you agree? Now, if we scroll all the way to the bottom, there should be a key. Does this match what we came up with? I can't see mine anymore, so I'm trusting you guys. Looks good? Awesome. Okay, so that was one. Pretty simple, right? So if you're adding, you just take things that are in the same position and you add them together. Now, number 3, let's go through the same thing. So Josh, what is the order of the first matrix on number 3? Yes, Josh. The other Josh is online now, so it's just, you're the only Josh. Alright, so 6 and 4, so that gives me 10. Alright, why don't you take that first row, and then we'll have Izzy do the second row, and Mikkel do the third row. Sounds great. Izzy, will you take the second row? You're all right. We're just getting over spring break, right? All right. So then, Mikkel, bottom row.
1 plus 4 is 5. -3 minus 3 is -6. And then -4 minus 1 is -5.
There we go. We check our work at the bottom or the back of the page. Does it match? We feel good? Okay. Pretty easy stuff when you're adding. You're just adding, okay? Okay. Now, what if we're subtracting? Well, then you're going to be subtracting, right? Same idea. Just be a little bit careful. Now, notice on number 4, you're going to add multiple times. Is that okay? It's the same idea, right? Let's actually try number 6. Okay? Now, where people might mess up on this is trying to do too much in their head. Where they might say, oh, I'm going to do 3 minus 6 minus a -5, and then they mess up with the negatives. So let me show you 2 things that you could do on this. Number 1, could you... If I had, let's say, 6 minus 5, can I think of that as 6 plus a -5? For people who don't like subtracting, is that a different way we could think about it? So, could I, with these, if I don't like subtracting, could I distribute that negative and think of it as adding? Like if I want to take 3, 1, -4, and -3, and I say, I don't like subtracting, so let's just add that, and then distribute the negative here. What would this next matrix look like if I did that, Payne? Awesome. Let's do that again for this next one. What is that going to look like, Charlie? And now if I'm adding, I'm just going to add those all together, right? Allie, can we add those together? What's the size of all the matrices? The order. Individually. Except switch that. There we go, rows by column. Doesn't really matter with the adding and subtracting as much as when we get to multiplying, it'll make a big difference. But yeah, they're all 4 by 1, right? So we can add them. So then tell me what I'm going to get when I do that, Allie. You're going to take actually the top row, and then Angelina's the second, third, and then Kimberly the fourth.
You're going to
get... well, this will be -3 plus 5. All right, cool. Angelina, you got the next one. There we go. All right, Ofa, what about the third row? All right, and then Kimberly, last row. Okay, and what are we going to do after we get an answer? Check our work. Does that match up? We're feeling good? Okay, so adding and subtracting pretty easy. Now, could we also have just combined one at a time and then said, okay, let's add those or subtract these, and then once we have our difference, then let's subtract the other one. Sure, there's multiple ways you could do it. Just always check your work to make sure you're doing it correctly, okay? Feeling good with add and subtract? Okay, let's go back to your notes now. We're going to talk about what's called scalar multiplication. That's when you're just being multiplied by a scalar, which could be a number. We kind of already did this with distributing the negative, right? It just means you multiply everything in the matrix by a negative. Now we're going to multiply it by a number, okay? And it's actually really easy. Let's look at 5, 9, 11, and 13. So going back to your assignment, I didn't mean 5. Let's do 7, 9, 11, 13. So starting with 7. So do you see how on number 7 we have this 5 just hanging out? What is that 5 doing to the matrix? It's multiplying, right? So I need to distribute the 5. We're used to distributing like polynomials, and we'll show it kind of like the lines that we're multiplying to all of those. We're doing the same thing here, but I'm not really going to draw the lines, okay? I'm just going to have, well, I guess I'll draw it here. So 5 multiplies to negative 2, and what does that give you? Negative 10, and then 5 multiplies to negative 4. 20, and 5 multiplies to negative 1. Negative 5, and then that's it, right? It's just like distributing with polynomials, but now it's just going into every element in the matrix, okay? Let's look at the same thing for number 9. This time, the negative 5 is getting distributed to every term in here. Okay? So let's just kind of walk through this. Negative 5 times negative 5, what is that? 25. Negative 5 times 1? Negative 5, right? Alright, let's pick up Brenda. You take the second row, Brandon the third one, and then Micah the last one. So, Brenda, what do we get for the second row?
35.
Awesome. Brandon, third row? Alright, and then Micah last row. 0, negative 1. Alright, you guys get the idea with scalar multiplication. It's just distributing, right? Nothing too crazy there. Now, let's combine that with adding or subtracting. So, let's do 11 and 13. Before we do, let's take a big step back and get the big picture here. What's going on here, okay? I've got a negative 3, and it's distributing to the difference of those two matrices. So what's going to be our order of operations? What are we going to have to do first here? We're going to take care of the work in the parentheses, right? We're going to subtract, and then after we find the difference, what are we going to do? Okay, so cool. Kara, will you start out with that subtraction? First off, are they the same size? Can we subtract? What are we going to get when we subtract those?
Oh wait, I lied. 1.
Positive 1,
And then negative. Sorry, I can't see. Negative 7. No, sorry.
Okay, pause. I'm going to pause you on that, because I'm having the same thing in my brain. Can we just distribute that negative first? Is that okay? Would that make it a little easier? I'm going to do that, just because negatives can be confusing. So I'm going to keep that the same. So we have negative 6, 1, positive 6, and negative 5. Did I change those signs right? Class effort. Okay, cool. So now, Kara, let's combine those now to make sure we're getting the same thing.
Okay, negative 10. 1. 5. And negative 3.
Awesome. Thanks, Kara. And then Spencer, let's distribute that negative 3. What do we get when we do that? And then what are we going to do now, guys? Flip our paper over. Check number 11. Adam's already there. Is this right? Oh, I thought he had it. We look good? All right. Good job, guys. So this is kind of using multi-step problems where I'm going to have to do more than one thing. In this case, we subtracted, and then we did a scalar multiplication. If we look at number 13, just as a class, let's talk about this. What's going to happen first here? Multiply by that -2, and then we do the subtracting. I'm going to give you guys 2 minutes on this one. 1 to 2 minutes here. I want you to walk through this, and if you want to check your work with your neighbor, do that. But just try this on your own, okay? All right, let's kind of come together if you're still working on it. This is what I got. I got 9, -3, -16, 2, 5, and -4. Is that what you guys got? Is that what it says in the back? Awesome. Okay. Now I'm not going to call it cheating. I'm going to call it using good skills here. But what I did is I just said, hey, what happens if you get a negative times a negative? Positive, so then I just distributed 2 and added.
So that 2 right next to the -16 is supposed to be.
You are right. Izzy, I left that in on purpose to see if anyone would call me out on it. Thank you for having the courage to do that. Except I'm lying, I just messed up. So good job. Okay, 2 + 6 is 8. Are we good now? Man, those people when I said, is this what it said in the back, and you said yes. You lied to me. Okay. All right, let's go back now. So, did we do what we said we were supposed to do there, 11 and 13? Do you guys have any questions up to this point? Matrices aren't too bad, right? So if you're adding or subtracting, what's the only rule? You have to be the same order, right? The same size, okay? With scalar multiplication, you just distribute it to everything. Now we're going to get to one that's just a tad bit tricky. It's not horrible, it's just a tad bit tricky. It's called matrix multiplication. Let's go through your notes here and do some examples with this. Okay, now this is going to have a lot of the verbiage of like how to do it, which is kind of confusing. But here's what I'm going to just tell you, okay? If I have a matrix, let me get out a pen. And let's say the matrix is a 2 by 3. I actually can't multiply that with another matrix that's a 2 by 3. The rule is if I'm going to multiply this 2 by 3 matrix with another matrix, this inside number has to match up. So if I have a 2 by 3, and I have to have it multiply with another one that has a 3 as its row, okay? So the number of the columns here has to match the number of rows there. So I need to check this. That's got to be my check there. I can multiply those together. Now, the resulting matrix, the product, is going to be a 2 by 2 matrix. So, before you multiply, what you do is you're going to compare the dimensions of the first matrix with the dimensions of the second, also known as the order or the size, okay? You need to make sure the inside numbers match, and the outside numbers is going to be what you get when you're done. Okay? Let's do an easy example. Here I've got matrix A and matrix B. Tal, what are the size of A and B?
1 by 1.
Well, this is a 1 by how many columns?
0.
You've got 3 columns here.
Oh,
So
yeah,
you have
but-
1 row and then 3 columns here, okay? We want to multiply that by B. Can we do that? Well, what are the dimensions of B? What's the size here? How many rows are there?
3.
There's 3. And how many columns?
1.
So based on what I just told you guys, can we multiply a 1 by 3 with a 3 by 1? Yes, because what are we checking? Do the inside numbers match up? And they do, right? Now, what will the resulting matrix, what size will it be? It's a 1 by 1. What does a 1 by 1 matrix look like? It's just one element in it, right? It's just got one element. Okay, so now, let me show you how this works. So here's our 1 by 3 multiplied with a 3 by 1. What's going to happen is we're going to take the 1 and it's going to multiply with the 4. Then we're going to take the 2 and it's going to multiply with the 5. Then we're going to take the 3 and it's going to multiply with the 6. So you can kind of see that down here. So I'm trying to color coordinate this. 1 times 4, which is just 4. Okay, so I've got 4 right there. Then we're going to do 2 times 5, which is 10. And then lastly, we're doing the 3 by 6, which is 18. If I do 4 plus 10, I get 14, and 14 plus 18 is 32. That's how you would do matrix multiplication. The associated row kind of shifts over and multiplies by the column. Okay? Now, it takes a minute for this to sink in. Let's do a couple more examples, okay? Let's go to, example 4 here. Okay, Adam, help me out. I want to multiply A and B. What is the size of A and what is the size of B?
A is 2 by 3
3
and
by 2. So Adam, can we multiply those together?
Yeah.
Yeah. How come?
Because they have the same column size.
So this column and that row match up. That inside one matches up. Okay? What will the resulting matrix be when we multiply these together? A 2 by 2. Okay. So now I'm going to actually just write this out because I feel like it's easier when they're right next to each other. Okay? So I'm going to take 2, 1, negative 3, 0, 1, 2. And we're going to multiply that with 1, 0, 1, and negative 4, 2, 0. Did I copy that down right? Now, remember when you're doing your order, you always do row, then column, right? When you're doing multiplying, what we're going to do is we're going to do row by column, and then we'll switch row by column. So I'm doing first row with first column, then first row with second column, then I do second row with the first column, second row with the second column. So I'm going to just write that out kind of like a little abstract here, and you're going to be like, that looks a little weird, but it'll make sense when we're done, okay? So what we're going to do is we're going to take row 1, multiply it with column 1, and that will give us that element here. Then we're going to do row 1 and multiply it with the second column, add it all together. That gives us that other entry right here. This is going to be row 2 with column 1, and this is row 2 with column 2. Now I'm just kind of big picture, that's what it's going to look like. Let's go through and do the math now behind all of that, okay?